What's up, Trig? This is Mr. Carlson, C-squared mathematics, and now we are going to finish 7.3 going through polar equations. Bell work, the homework quiz, objective central question, polar equations. It's going to be pretty much as simple as it was yesterday, probably even a little bit more simple because it is a lot of plug and chug, and then the summary and closure. I only have one question on the bell work for you guys, and it's going to be this one. This is probably the hardest thing that we learned yesterday, going through the multiple representations, the three different categories on how I can actually get the multiple representation. So I only want to go through this one for the sake of time. This one's asking you from MathExcel, plot the point at the right, this point. I'm not going to actually plot it for you guys. You can plot it yourself. Okay, it's not negative or anything, so it's a very easy plot there. And then find other polar coordinates for each of the following. Okay, so I'm just going to do that. You can plot it yourself. Ready? So this first one, A. What is this one actually asking? If it's negative 2 pi to 0, what I'm going to do is I'm actually going to subtract 2 pi. So I'm going to subtract 2 pi, and then I'm actually going to keep r the same. Okay, so I'm going to subtract 2 pi, I'm going to keep r the same. If that confuses you, this little thing here, I'm just going to do a comma, I guess. But it's really just a semicolon. Okay. Surprise. All right, this one. What am I going to do here? If it's 0 to 2 pi, I'm going to, if I'm given this, now look at the point, look at the angle. It's 11 pi over 6. Am I going to add pi or subtract pi? Now, why would I want to add or subtract pi? Because I want it within the unit circle bounds. So I can't add or subtract 2 pi, or else I'm totally outside of those bounds. So I need to add or subtract pi. Now, it depends on what the angle is. If this angle is really small, then I'm probably going to add it. If it's really large, then I'm going to subtract it. Since this 11 pi over 6 is towards the end of the unit circle in quadrant 4, that means I'm going to actually subtract pi. Okay, and then I'm going to make sure I get a negative r as per my distinctions that we learned yesterday. Okay, that's what I'm going to do. And now my last one, let's switch to blue here. My last one, it's going to be, it's also negative r because it's less than 0. And this is going to be greater than 0, which means my r is going to be the same. And since it's once between 2 pi to 4 pi, I want to kind of enlarge that angle, which means I'm going to add 2 pi. So I'm going to do add 2 pi. Okay, add 2 pi, and then this is going to be just r. All right, so subtract 2 pi r, minus pi, negative r, and then add pi, just straight up r. Let's go to it. This is going to be A. Ready? So I'm going to first find what my thetas are. So this is 11 pi all over 6. And this is going to be minus 2 pi, which equals, this is 11 pi all over 6, minus 12 pi all over 6. And this equals negative pi all over 6. So that means my point here is going to be 1 because it stays the same, and then minus pi all over 6. Now, before I actually box this, even though I just did, is it within my interval? Yes, it is. It's totally within that interval for my angle, so I'm solid. That's my point. All right, so for B, okay, I'm going to subtract pi. So I'm going to take 11 pi all over 6, subtract pi. That gives me 11 pi all over 6. And I'm going to subtract 6 pi all over 6. Okay, this equals 5 pi all over 6, which means my actual coordinate point is 1 comma 5 pi all over 6. And that is my final point. Is it within my bounds? Is it within my interval? Yeah, it is. Absolutely. I'm solid. I am happier than a dog on Christmas. We all know how happy they are. So C. Now, I want to add 2 pi. So I'm going to take 11 pi all over 6. I'm going to add 2 pi. This gives me 11 pi all over 6 plus 12 pi all over 6, which gives me a whopping 23 pi all over 6, which, when I put it in my coordinate system, oh, sorry, I need to put this one as a negative. Make sure it's negative. When I put that in my coordinate system, I get a positive r, so that means I have a positive r, which is 1. Not like this. Don't make that mistake like I do. You can get partial credit on it if you do make that mistake. No big deal. And then I want 23 pi all over 6. That is my final point. Is it within my interval? Well, it's a rather large angle. Does it go past 4? Well, how many times does 6 go into 23? Only 3 times with a couple left over, so it's definitely not past 4 pi. I'm solid. Okay? So that is how you would do those questions. I hope that makes sense. So now I'm going to erase, and we're going to get started on the homework quiz. It's 5 questions, 25 minutes. Polar equations is the next lesson that we're going to get into. So please review your answers, send any partial credits to me if necessary. Get started. If you want to, it's optional, but you can if you want. It raises your grade. Saying. Okay, so for the objective and central questions, how do I use the polar coordinate system and convert between the rectangular coordinate system? So really, we're going to be doing mostly conversions. That's primarily what we're going to be doing the whole day. We're mostly going to just be doing conversions between polar to rectangular and rectangular to polar equations. So it's really nice. I really like this. By using conversion formulas, how can I go and convert? I can convert by using my conversion formulas, and I'll show you what those are now. I want to first know what rectangular to polar is. So what are rectangular to polar coordinates? Okay, it's the xy coordinates for rectangular going to my polar coordinates r theta. Okay, r theta. So now I can convert between also rectangular coordinates using x and y to polar equations using r and theta. The polar equation here is an equation whose variables will then be r and theta, which we should already know. Okay, it doesn't surprise us. If I have an equation that's rectangular and I have y and x, just like a linear equation, y equals 3x plus 5, that has the variables y and x. It's a rectangular two-dimensional equation. Now, if I have a circular dimensional equation, such as a polar equation, and my coordinate points are r and theta, of course, I'm going to see r and theta in my equation. Okay? So to convert between a rectangular equation and a polar equation, I have 2 real steps. The first step is to replace x with r cosine theta. So I want to try to get my equation, my rectangular equation, to become r cosine theta. So I want to make sure my y's and my r's are switched out with, polar coordinates, polar terms. Okay, because if I have an x and y still chilling in there, then it's still rectangular, and I don't want that. My second step is, of course, to solve for r. And that can be a variety of different means. It can be very difficult, and I'm going to show you one that's actually rather difficult. Okay, let's get started. Yes? Yes. This is just an example of what polar equations will look like. So if you want to write that down, go for it. We can graph them. I'm not going to graph them because we're going to save that for the next 2 days when we graph them. We can graph these polar equations, but I'm not going to, and I'm not going to be using Desmos really at all today. I know, shocker. Oh, geez, it breaks my heart. But we're going to be doing it definitely for 2 days, so hopefully it makes it up. Okay, rectangular polar, that's what we're going to be doing first. It's going to be asking you to do these two, A and B. You're given rectangular equations, and then you want polar equations. So this first one, what kind of function is this? Well, this function right here is actually just a linear equation. This second function right here is actually a circle. Okay, so if you don't know that, maybe you should go back to geometry and learn a little bit more. But either way, I'm telling you it's a circle, so I'm sorry, that was mean. So A, let's go to A first, y plus x or x plus y equals 5. Ready? I want to basically just substitute these things. And there's a couple ways that I can actually do this, to be honest. It really does not matter one way or another. Okay, I see x and I see y. I know at the very beginning my x equals r times cosine of theta, and then y equals r times sine of theta. So at the very beginning, I know that those are the two I'm working with primarily. So I see y and I see r. I see x and I see y. Sometimes I think I'm honestly dyslexic and I'm teaching math, which is kind of a comical joke on my part. Anyways, x and y, what is x? It's r cosine theta. So r cosine theta. I'm actually just going to substitute that in. What is y? Y is plus r sine theta. And this equals 5. Now, when I get to this part, then you have to start using your algebra. What is common in both terms? Well, r is common in both terms. So that means I'm going to say r. I'm going to factor that out. This is cosine of theta, and then this is plus sine of theta equals 5. And now what I'm going to do is I'm actually going to divide by cosine plus, I'm going to divide by cosine plus sine, which means what I get is r equals 5 all over cosine of theta plus sine of theta. This is my final answer. Not too bad, right? Not too terrible. So it takes a little bit of creativity to know how to get the r by itself, because that's really what you want to try to find. You want to express it in terms of r and theta, but you want to basically say r equals. Okay, that's really what you want to do. R equals theta or some sort of thing like that, because rectangular coordinates, it was really y equals x, something like that. So you want to try to flip them and try to creatively get to r equals. Let's do the next one in red because it's my favorite color. This is a circle where its center is 1, 0, and its r is 1, just FYI. However, what I'm going to do when I simplify this, I'm actually going to multiply this out first. Now, some of you may be thinking, hey, Mr. Carlson, can I just substitute straight up r times cosine right here? You could, but notice how this is a squared here. That's going to give you a lot of pain, okay? It's best to just, and then you'll have to simplify it out anyways. It's best to just multiply it all out, then start substituting. You will still have to do the squared part, but it's just going to be less work on your part with all the r cosine. You can just do it with the x's and the 1s. So when I FOIL this out, what I have is x squared. Wow, that's a 2. What a pathetic looking 2. Okay, so this is squared. All right. And now what I do is just FOIL it out. So I'm actually going to go to town on just FOILing this whole thing out. So that's just algebra. It's nothing really too intense. This is plus y squared equals 1. Okay. I'm actually going to simplify this down a little bit more. So this can become like this. So this is x squared minus 2x plus y squared equals 0. And now that I have this part, I'm actually going to start substituting in my y's and my r's. Wow. My x's and my y's for r cosine theta and r sine theta respectively. So what is my x? My x is r times cosine theta. And then I do need to square this. And we're going to get to that in a little bit. And then minus 2, and then this is r cosine of theta. It's r cosine of theta. And then this is going to be plus my y, which is r sine of theta, and then squared equals 0. So that's what I have. Okay? Good so far? So far, so good? So when I square this, what happens is this actually becomes r squared, and then this becomes cosine squared theta. This just becomes negative 2, and then r cosine theta. I mean, that's just chilling. And this also becomes r squared, and then sine squared theta. Okay? Now, here's the interesting kick. Are you ready? I'm going to kind of rearrange this. All right, I'm just going to kind of rearrange. And how I'm going to rearrange is I'm going to put these two together. And you may be seeing, and you should be seeing, there's an identity chilling in here. Okay, so I'm going to actually put these together. I'm going to just rearrange it. I can do this in mathematics, no big deal. And then sine squared theta. And then this is minus 2r, and then cosine theta equals 0. So I just rearranged it. Now notice how in this, you can now have the factoring opportunity to take r squared out. So I'm going to take r squared out, and then what I have left is cosine squared theta plus sine squared theta. Now, again, you should be thinking there's an identity chilling in there, because there is. Okay, it's a Pythagorean identity. So this is minus 2r cosine theta equals 0. Okay, let's finish the work up here. Obviously, this is the identity, so that's 1. So 1 times r squared is just going to be r squared. And this is going to be minus 2r. My computer's being really slow right now. So minus 2r, and then cosine theta equals 0. Okay, that's what I have so far. Now when I get to this part, I can actually factor out another r. So that's what I'm going to do. I'm going to factor out an r. So then this is going to be r minus 2 cosine of theta equals 0. And of course, I have parentheses right there. Okay, so this is r minus 2 cosine of theta in the parentheses. Now, when I get to this point, guys, the interesting part is this. I can set each of these equal to 0. So I can set this one equal to 0. So this is going to be r equals 0. And I can set this one, this product, this is the 0 product property, equal to 0. So r minus, and then 2 cosine of theta equals 0. Okay? So, of course, the second one, I can just solve for r real quick. So this is r equals 2 cosine of theta. And then this is done. All right. Here, though, the problem with this one is r equals 0. I can't have r equals 0. If I have r equals 0, there is no literal point. There's no equation at all. Okay, so this right here is technically nothing. I'm not interested in that equation. It's just almost like an extraneous solution if it were. So I'm only interested in this one, and that is my final answer. Okay? Fantastic. So that is all we need to do. Perfect. Let's erase this. Make sure you get it copied down. The second one was a little bit obnoxious. I understand that. But it is kind of fun, kind of just simplifying down and kind of get into it to find your polar coordinate. All right. So I want you guys to practice now. Practice using these. I'm going to not necessarily show you the whole work, just because I don't want to take up any more of my time, to be honest. I'm just going to show you the answers. But hopefully you can get to the answers. Do it exactly how we did it in the last slides. In the last slide here. Practice. Seriously try to get them yourself. I really want you to try to actually at least do one of them. That would be great. So I'm going to pause. You should pause. And then when we come back, we'll have both the answers on the screen. Okay? Perfect. So these are the answers. Again, it is almost exactly the same process as the previous slide. So if you followed along with the previous slide, you could probably do it. Then I encourage you to try to get these answers. But these are the answers for these two. Try it. Practice it. That's the only way you're going to really get good at the math. I promise you. All right, so let's go into the other conversions. Let's go to polar to rectangular. I only have 3 more slides left, and then we're going to be done. Isn't that exciting? So polar to rectangular, we will have to use some familiar formulas just like this. Now, I'm going to put them all there because, honestly, we have to use almost all of them in one way, shape, or form. Going from polar to rectangular coordinates is, or polar to rectangular equations is very, very difficult indeed, because you really have to be creative in your algebra skills. So you have to use certain skills like square both sides. You have to use maybe possibly an identity. You have to use oftentimes what we call the taking of the tangent of both sides. So you take the tangent of it. It's very interesting. Almost like if you remember from Algebra 2.2, when we said take the log of something during logarithmic equations. If you remember that, or that familiar formula, familiar phraseology, then similarly, that's what we're going to be doing here, but with tangent. And we also have to multiply both sides by r. Now, these are just a couple of the ones that we will be using. I will show each of these in the next slide and how to relate to each of them, how I can get the rectangular equation from each, using each of these algebra skills or strategies. However, these are definitely not the only ones that you pretty much will use, okay? But primarily, these are the ones that you will use. So, kind of looks maybe a little scary, but I promise you it's not. It's just really fun math, personally. I really like it. So, let's go through it and see what we got. There's these four, so I'll give you a second to write those down, and then we'll get started. Again, I'm going to be utilizing those algebra skills, the identity, the square root both sides, multiplying by r, and so forth. I'm going to be using those algebra skills, those trigonometric skills, in each one of these. Okay, let's go through A. So A, r equals 5. It is definitely a polar equation, rather odd polar equation, and we want to convert that into rectangular equations. So this is what I mean by kind of squaring both sides. So watch what I do here. When I square both sides, what happens is I do get r squared and then equals 25. Now here is where the algebra skills come into play. I can take this and substitute a common thing that we just learned in the previous slide. Remember, x squared plus y squared equals r squared. Okay, so using this knowledge, I can then substitute what? I can substitute x squared plus y squared, and this equals 25. I know I am done when all the thetas and the r's are all the way out of my equation, and I'm left with just x and y. I'm left with just x and y, which means I am finished. Okay, that one was not too terrible. It looked kind of like, but again, it takes practice to kind of figure out what to do here in each situation. This next one, what if you're just given theta? What do I do here? Well, if I'm given theta, remember, I can use what I call the tangent. So I can do the tangent of both sides. I can take the tangent of both sides. So what does that look like? That means I'm almost kind of inserting tangent into the equation. But what I do to one side, I must do to the other. And this is completely algebraically good, well, and fine to do. So now what I have is tangent of theta equals the tangent of pi all over 4. Okay? So the tangent of pi over 4 is just 1. So it's just 1. And then this, and that's just my unit circle here. And this is theta. So now what we're going to be asked is, okay, what is y equal? What is y equal? What is x equal? Like, I need still to get it in x equals form, right? Like, I still need to somehow get it to be x equals or y. I need y and x into my equation, and right now I just don't. So what can I do? Again, I can use my knowledge of trig functions and how they relate already to my rectangular coordinate functions. Meaning, what's tangent actually equal? Using the unit circle, I know tangent actually equals y all over x. And this equals 1. Boom. And so, of course, I just times x. So that means y equals just x. Notice no thetas, no r's. I'm done. Rectangular equation. So these ones are a little bit tricky because you do have to kind of, there's almost more than one way. Like, you have to kind of look into the question and pull out necessary things. Very tricky indeed. All right, let's go to our purple one, C here. What do I do for C? Okay, well, first of all, I want to use an identity. I don't like cosecant. That's ugly. So what I'm going to do is actually rephrase this to be 1 all over sine of theta. Now, again, my goal is to get y and x. Y and x or x and y. It does not matter. I need something in the equation that says y and x. Yes? So in order to do that, I have to kind of manipulate this in order to somehow see if I can get y or x. Now, what if I multiply by sine of theta? Do you start to see where I'm going with this? If I multiply by sine of theta, what I get here is nothing on that side besides the 3. But on the left side, I have r times, I hope you see it now, sine of theta equals 3. What is that? What are those? Those are definitely not crocs, okay? This right here is straight up y, okay? So again, creatively looking into what you can do to manipulate your equation to get to x or y. We got to y, that's amazing. So that means it's just y equals 3. Do I need to have an x in there? No, I do not need to have an x in there. I told you that. Like, all I need is some sort of resemblance to y or x. If they're both in there, great. If one of them's in there, that's fine. As long as the r and the theta are out, I'm solid. All right, let's do our last and final one. This one is probably the trickiest one, but I am going to what we call not just square both sides, but specifically what I'm going to do. And I think you could probably honestly get to this if you square both sides, but the easier way is to just times both sides by what we call r. So that means right here I have r squared equals, and then I would have -6 times r, and then cosine of theta. -6 times r and cosine of theta. Now, a couple things here. For one, what is that? What are those? Again, definitely not crocs. This is definitely x squared plus y squared. We did that in the first problem right here. And then this will equal -6. And what is this? That is just straight up x and then multiply. And so if I want to combine everything together, I can just say x squared and then plus 6x and then plus y squared equals 0. And this would be my final equation. Okay? Now, technically, this is right. Yes? Technically, this is right. However, MathXL more than likely won't accept this. So this is nice, it's correct, but look at it. MathXL will more than likely not accept this, which means I need to put it into a form that MathXL will accept, which means the only way I can do this is if I complete the square. Do you remember that from Algebra 2? If I complete the square here. So what am I going to do? Is this correct? Well, sort of. But let's just hold off on our little boxy. And let's see if I can actually complete the square here to make it a little bit more MathXL user-friendly. How about that? Again, my computer is being really slow, so I apologize. Okay. So how do I do this? Well, if you remember, to complete the square, all you have to do is just say x squared, and then plus 6x, and then plus blank, whatever that blank is. I'm going to show you how to get that blank. And then this is going to be plus, and then y squared equals 0. Yeah. The reason why I'm going to do this is because this x portion is not complete. My y is technically complete. Okay, it's my center of, because this is a square, or sorry, not a square. This is a circle. This is a circle, and my y, my center, would just be something comma 0. But the problem is you don't know what that something is until you actually figure it out by completing the square. I need to look at 6, and that is going to tell me what that blank spot is. Okay, so that means I go to 6 divided by 2, and this is squared. 6 divided by 2 is just 3, and then 3 gives me 9. Okay, so 9 is what I put there. But what I do to one side, I must do to the other, which means I also have to put 9 right there. Okay, so now what will this actually equal? I can factor this into the perfect trinomial, and that will actually equal accordingly. This right here, x squared plus 6x plus 9. This is going to be x plus 3 squared. And then this is going to be plus y squared. And this equals 9. This is more than likely what Math Excel will want. Okay, that's more than likely what Math Excel will want. And yes, that is kind of a butthole, okay, to do. I get that, so I apologize, but it is what it is. All right? So I'm going to now give you some practice questions. I'm just going to give you the answers as well, just like the previous practice checkpoint. Again, but I highly encourage you just pause the video on the next slide so that we can actually learn the math. I want you to learn the math. And so please, please, please don't just skip past it. Actually try it out. And if you can check it right now to see if you can get it correct. So let me erase. Polar to rectangular. Let's go through some practice questions. Go ahead and pause the video, and when you come back, the answers will be there. Very, very similar questions to what we had before. I'm not going to show you the work unless you actually email me, like, can you show me the work? I will. But just pause the video, and I'll show you the answers, and hopefully you'll be able to follow the same process and get the right answers. Boom. Those are the answers. Look very, very familiar from our previous slide. So if you haven't tried those, I encourage you to try at least 1 or 2 of them to see if you can get these, maybe even D, because that was probably the most difficult one. So if you can complete the square on the y value there, then that would be great, the y variable. Try it yourself and see what you can get. I'm going to erase. And now we're going to get into the summary. So I really like this lesson just because it was a lot of just plug and chug, and it was a lot of identities, and I just kind of compiling everything together, and that's really, really why I like that lesson. Okay. So what did we learn? Polar equations. We learned how to convert an equation from rectangular and polar coordinates, and then we also learned to convert an equation from polar to rectangular. We didn't really do a lot of calculator work or anything like that, but that's okay. We're going to be doing a lot of Desmos in the next 2 days. Make sure you take time to study for your retake, the makeup for the Unit 2 test, and do the homework. There will probably be, yes, a homework quiz for tomorrow, but again, it's optional. And this is a great lesson to do the homework quiz on because it's very simple. And so I'm sure a lot of you could probably raise your grade just a little bit by doing the homework quiz. But until next time, guys, I'm Mr. Carlson, C Squared Mathematics. Be sure to like and subscribe. Make good choices.